All right, here goes. I've promised a lot of people that I was going to do this a lot sooner, but better late than never. We have here the EnviroFit rocket stove. I am going to light this sucker up, and we're going to cook a little ground beef on it. I just wanted to create a little YouTube video to kind of show people how these work, because I've been talking about these rocket stoves pretty excitedly for a while now, and I wanted to give everybody an idea of exactly what they are. So, I'm going to be building about 4 of these for Christmas presents for various of my friends, and this is a commercial version, and I just purchased this to get some design ideas. I knew that a lot of research had gone into this particular model in terms of its burn efficiency and economics. These are recommended by various humanitarian organizations for efficient use of cooking fuels in the third world. My primary purpose for this particular device is going to be for emergency well, okay, I shouldn't say that. Primarily, when I kind of got it, my first idea was emergency cooking uses. But, if this thing turns out pretty well, I might use this as a stovetop for Dutch oven or cast iron cooking, which, I don't mind if it gets a little smoke or ash or, blackened from the soot of a burn on it. So, maybe I can use this for more of my cast iron cooking. But anyway, so let me give you an overview of the device. So it's got 2 little handles on the sides, which is pretty nice. It's essentially a metal bucket here. And then the inside is looks like just clay. Now, the ones I'm going to make is going to be a combination of clay and perlite, but this one here is just clay. It comes with a little rack for feeding the fuel, and there's the burn chamber. It's interesting that the burn chamber is so large compared to the chimney. I'm not sure what that's going to do exactly, but you put your fuel on top. This rack allows oxygen to come up underneath your fuel, and essentially what this device does is the clay acts as a huge insulator so that none of the heat from the combustion is radiated out from the fire, that it actually has to move up because there's just too much insulation for it to radiate out. And then as that heat cannot radiate out and is forced up this combustion chimney, it begins to build in temperature to a point at which it actually begins to burn the smoke and the unburned carbon molecules, the smoke carbon molecules, which still have some chemical energy left over, which normally would just escape. And I've seen various things on this. This is something in between 70 to 150% more efficient than an open fire. So the idea here is that we're going to be able to use this very small amount of fuel to basically, have a single burner going. And in the last 2 weeks, every time I walk the dog, I just pick up sticks. And this is the stick pile I've accumulated in just 2 weeks of walking around the neighborhood, picking up sticks and bringing them back here. And I'm going to cut a few of these up, and we're going to use them as fuel for this device. And I'm going to cook up probably like 6 pounds of ground beef, a couple pounds of which are going to be for taco meat, and the others are, I'm not sure yet, I might just freeze or whatnot. Alright, thank you very much. Alright, so the rocket stove has been loaded with fuel. I put a little paper down at the bottom, and we're going to light this thing and see how it goes. Got my handy dandy little lighter. And I see a little smoke. A little more smoke. Yeah, there's some really nice airflow there because I barely did anything to really, I just bunched up some paper from a old sugar bag and took the whole bag, put it in small little pieces, and yeah, the airflow is really nice, much better than I expected, and the smoke is puffing away. And again, it is going to take some time for the combustion chamber there to warm up to the point in which we get a real rocket effect. But essentially, as the first half inch or centimeter or two of insulation absorbs all the heat it's going to absorb. And the heat is very slowly radiating out towards the rest of the insulation. It's going to, you know, basically require the heat to be reflected away from, you know, the heat wants to radiate out, but the insulation is going to prevent it from radiating out, and it's going to slowly warm up that combustion chamber to a place where, you know, we begin to get a very, very hot fire going in the middle of that chimney. And it's going to be, you know, I think I've heard this thing is rated for, I want to say 12,000 BTUs. So that's a pretty potent little stovetop burner we're creating. And now we're getting our first few flames just popping right up there. I got the Dutch oven to the left, which is going to go on this, which we're going to cook our ground beef in. And I just wanted to, you know, get some video of the actual warm-up period for this rocket stove. I just want to break this sucker in, see how it worked. You know, if I ever do use it, I think I mean, what's the alternative? You know, the alternative for me to use a Dutch oven in the space that I have and everything is really to get my hibachi. I got a cast iron hibachi, and to get that sucker warmed up with lots of charcoal, and you know, and use a Dutch oven that way. Or, you know, a frying pan. But, you know, the hibachi has got a nice, you know, don't get me wrong, the hibachi's got really nice, great heat, but it does use up a lot of fuel. And of course, the fuel that it really wants is going to be charcoal for, you know, long-lasting burn. And what I like about this product here is that potentially, you know, if it works out, and I'm sure it will, if it works out, it just uses natural fuels. You know, it just uses, you know, the various sticks that you might find. And, you know, you can be like a little eco-walker, right? So, you know, you're walking along the neighborhood and you see a stick and you pick it up and it goes in your pocket, or you carry it along with you, drag it behind you. And, you know, this becomes a way of, you know, reusing a lot of the fuel that you might normally pass up as you're walking by. I mean, think of these little sticks as little bundles of propane that you could be burning and using to cook your food. And certainly in the wintertime, like right now, it's December, surprisingly we don't have any snow, but you know, in the wintertime I'm not particularly concerned with cooking indoors, because I figure any heat that I'm using or any energy I'm using to cook indoors in the wintertime, well, that's just heat that, you know, is going to be radiated out into my house, which I'm going to heat with, you know, the furnace anyway. So, you know, really, for something like this in a situation in the wintertime, I'm personally not going to use it, even if it does use natural fuel, merely because, you know, essentially, you know, that energy I'm using right now, you know, even though I can't harness sticks for energy right now in my house, you know, at least I can use the natural gas that's in the stove to, you know, do something with, and it heats my house, and it's like a win-win. You know, you're heating your dinner or your lunch, and at the same time you're actually heating your house, you know, as a nice after effect. But geez, I mean, you know, if it's the summertime and you don't want that heat in the house, you know, if you're air conditioning the place, to have something like this is pretty nice. This would be really nice for, geez, if you were tailgating, or if you were camping from your car. I mean, it's pretty heavy. I think the weight on this particular product is 15 pounds. I suspect the ones I'm going to make out of the mini kegs and soup cans are going to weigh probably in the 12-pound range. It's going to be a mixture of clay and perlite. And, you know, the insulation required to make one of these is going to kind of necessitate a lot of that, you know, weight. You know, this isn't going to be something you're going to take backpacking necessarily. If you really want to go backpacking with something of the same idea of this, you're really looking at a Kelly kettle, which I have a Kelly kettle and I really like it. But I have actually another product that I will demonstrate not too long ago. It's actually from China. It's a stainless steel water pasteurizer, and it works very much the same way as the top end of a Kelly kettle. It's on a much larger scale, and it's actually situated very nicely for this kind of product. But yeah, so we got a little fire going. I'm going to let this burn for another 2-3 minutes. I'm going to slowly push the fuel, you know, into the combustion chamber, and just let that combustion chamber really heat up. And it's actually probably time to start putting some like bigger sticks in here. And it really is eating up the fuel nicely. Actually, as I did that, it seemed like a little bit of the flames died down. We'll see how that goes. I really like the rack in terms of allowing that air to come up from underneath the fire. That is a really nice feature, and it really keeps you from, you know, killing your flame. or your combustion by kind of preventing it from getting the oxygen that it needs. But already in just the, oh geez, this video is like 6 minutes and 30 seconds so far. You know, we've burned, you know, the sticks were out here before, and I've pushed them inward to a point where, you know, they're much shorter than they started out in just these few minutes. So I'm gonna let this burn, let the combustion chamber heat right up, and then we'll get this Dutch oven on. Okay, sorry. Well, so I just threw the ground beef on the Dutch oven, and this ground beef is straight out of the fridge, so it's cold, and it's probably 40 degrees outside, and so far, whoop, oh yeah, I need to feed the fire here. I had just come outside and I threw the ground beef on the Dutch oven, and suddenly I started realizing, uh-oh, we're losing energy in this this system. And so I moved real quick and just pushed some more fuel on there. And actually, just to make sure we're going good, I'll stick some new sticks in here. Alright, well, obviously, it really had the cast iron was heated up really nicely in the beginning, but the cooking, you can notice, I don't know if the sound is going to come through on the microphone, this little video recorder, tiny little thing, but yeah, we're basically not even boiling right now. So the energy that had been built up in the cast iron, stored in the cast iron, pretty much neutralized to less than boiling by the addition of, I'd say, 4 pounds of ground beef. I'm sure this will turn itself around, and you know, had I pushed the fuel underneath the into the combustion chamber earlier before I decided to throw the ground beef in, I think we would have had a little bit better results because we would have fresh fuel. But essentially what I've done is, you know, the cast iron was nice, piping hot, but the fuel was kind of low, and, you know, by throwing the ground beef on there, without having sufficient fuel in there, I put new cold fuel into the combustion chamber, and now it needs another couple, you know, maybe a minute or two to heat up. So this is a difference between if you were cooking with propane or Coleman fuel. You know, there's a little bit of lag in terms of how much fuel I supply versus how much heat output I get. You know, you can throw this fuel in there, but you know, it's gonna slow down. It's gonna take a minute or two before the energy of the combustion of these sticks is gonna build up to provide you sufficient cooking heat. So right in the beginning, I'm already getting boiling. So already we're back to boiling. Still not what I want. I want something. I mean, I would like to hear a lot of type of noise from this beef right now. So that's what I would like to have if I was on a propane burner. But you know, we are cooking with sticks here, so you know, we gotta cut a little bit of slack. But that's all right. I'm gonna stop the recording here, and we'll see how we go in a couple minutes. So about a minute has gone by since the last video, and we're okay. You know, the temperature at which we're getting now, the amount of heat that I'm getting now, is really what I would get if I had maybe one of my back burners on my stove, natural gas stove, if it was a full bore or 3/4 of full bore. I'm not real impressed. It's certainly enough to cook on. And, you know, this this Dutch oven is a rather large surface. And I put in a rather large amount of ground beef in here. So, you know, I don't expect miracles per se. But, you know, this is not exactly your 20,000 BTU stovetop burner, you know, with sticks. You know, this is not going to produce for you what a, you know, propane burner would produce for you. We are getting a pretty good heat from the sticks that we have here. You know, as you can see, the flames are going pretty good. The energy is consistent. I doubt that we'll have much of a, I doubt you'd find much hot spots in the cooking of this particular rocket stove. But, it's not exactly blowing me away right now. But certainly doable, you know what I mean? Like, this is a large Dutch oven. This is fairly thick cast iron. And, it's doing it, it's certainly taking ground beef from the fridge. And honestly, ground beef you shouldn't take it from, any meat. You shouldn't take it from the fridge to the stovetop or to the oven. You should warm it slowly to room temperature before it goes on there, just so you can get a nice sear. But, sometimes we have time for these things and sometimes we don't. So, pretty much at this point, my ground beef is completely browned. And so I'm at 2 minutes now. I think I was on 3 minutes and last. So basically, in 6 minutes, and I'd say 2 pounds of sticks, I have browned, 3 to 4 pounds of ground beef. And that's not too bad. That's not shabby at all. I really can't say that that's shoddy in the least bit. That's decent. So, can you cook on one of these? Absolutely. Is it hugely powerful? Is it 20,000 BTUs of heat? Well, no, but, it is what it is. You're using natural materials, and remember the carbon or the charcoal that's left over from this fire can be thrown in your garden or in your compost as biochar, and it'll provide really good carbon for your compost. And the fuel is basically free. So after you build the actual device, your fuel is free. And how can you argue with that? Essentially, the sticks that you're using as fuel represent stored solar energy. The plant is using, solar energy and converting that into sugars, and converting those sugars over into plant building blocks and, complex organic carbon molecules, which store energy, which we're now burning through a process of combustion. And then that process releases that stored solar energy to cook our food. So, we're using a fairly natural, renewable resource to cook a little bit of food for dinner. And, I'm not going to knock it. It's good. I'm perfectly satisfied with this product. I wasn't exactly sure what kind of heat output I would get. I almost kind of, anticipated a little bit more heat output. But this is fine. This is great. This is absolutely doable. You can cook for a whole family, or, I'd say this is probably, this one burner is enough to cook for anywhere from 6 to 10 people if you needed to. You can pretty much run this constantly. I don't think there's a limitation on how long you can run it. Like, it's not like after 2 hours you gotta let it cool down. The insulation is going to heat up. I'm touching the outside right now, and it's warm. It's probably 100, 110 degrees on the outside here. So, as it burns, I don't recommend touching this as it goes for an hour. I'm sure this will heat up. The insulation is only going to slow the heat radiation down. It doesn't completely stop it. So, this outside metal container is going to get very hot, and hence the handles. But, if it was an ice storm, a tornado, a natural disaster, here you have a source of, naturally acquired cooking fuel to cook pretty much anything you can cook on the stovetop. If you have a Dutch oven, you can basically bake inside of it. I'm going to show you some solar cooking in future videos, but I haven't completed my my solar cooking experiment. Now that my master's thesis is done, I should be able to put out a lot more videos like this, and just to show you different things. Probably my next project is going to be show you how a wood gasifier works, and wood gasification. So we're going to see that in the next few videos. But I'm perfectly happy with this product here. It's the EnviroFit rocket stove. Again, you can build these yourself with a number 10 can or a mini keg and some clay and some perlite as insulation and some soup cans acting as the stovepipe and the fuel inducer. I guess if you want to call that the place where the fuel goes in. And what's really happening here, I don't think I've explained it yet actually, which is interesting to me at least, is this is really nice technology. The The fuel goes in horizontally, as you see, and as this combustion chamber heats up, the heated gas naturally wants to go up. Hot gas, moves up. The hot gas is lighter because the molecules are spread further apart, and they want to go up because they're lighter, just like an air bubble wants to go on top of, up when it's surrounded by water, because the air bubble is much lighter. Or hydrogen or helium balloon wants to go up into the atmosphere because it's much lighter than the surrounding atmosphere. So what we got here is, as the combustion chamber heats up, the hot air wanting to move up, and because it's lighter, because it's been heated, naturally goes up, and it goes up that chimney, which draws in new oxygen into our combustion chamber, which is constantly feeding this chemical reaction we call combustion, and you really have a nice burn. Of course, as I explained before, the insulation around the chimney creates a really nice effect of multiplying that heat, keeping it from radiating out, and sending that heat upward so that it will, be burned, and eventually get to a temperature in which you are burning, hopefully, a little bit of the smoke. And the smoke is the aerosolized carbon chains, which, would normally just escape as a gas in an open fire. But hopefully in this system like this, that smoke is then burned a little bit. You're certainly not going to get anywhere near complete burn in such a short chimney. But if this thing were 4 feet tall, we would see much, much, much less smoke. And we're far beyond burned right now. I'm actually going to take this Dutch oven off the burner, and then I'm going to add some chili powder and some cumin. And so we're at 8 minutes on this video, 6 minutes. So in 10 minutes, your food is going to be cooked, So at least you can say that. In 10 minutes, you've cooked quite a lot of food there. And, who can argue with that?